Hi everyone. Today you see the title of what we have on the top of the screen, and I am hoping that you are coming to this video after already watching those other two videos. I'm hoping that you found Professor Schmohawk to be entertaining. The first video that I asked you to watch has got some considerable background in terms of working with some radicals. So there was quite a bit in that video that was a review, although I think it's going to be helpful. The beginnings of that video and the end of the video are what our real focus is for today. The second video that you watched really gives us a lead into where we go with some more complex exponents. So I'm hoping that you've watched those two videos and you were able to grasp what Professor Schmohawk was talking about. And what you see on the screen right now, there is a quick review quiz, if you want to think of it that way. That is a practice quiz that you should be able to tackle after watching those two videos. So if you have not watched those two videos, then please make your way there and then come back to this video lesson. For those of you who did watch it, followed the instructions, then we should be good to jump in on those 5 problems. So in question 1, I want you to write them as a single power. Question 2, I'd like you to write both of those as radicals. And in question 3, I'd like you to evaluate 8 to the exponent 2/3 and do so without using your calculator. Okay? So you work your way through, solve those 5 problems. I'm going to put up some final solutions and we should be good to go today. Okay? Pause the video now. Okay, we are back for today. So I am hoping that what we have in the first one, and I'm just pushed for space here so I could fit that whole thing on the screen. So I know you're going to have your answers underneath. I'm just sliding mine into the side. I am hoping that we have those for question 1, that we were good with these for question 2. And again, be very careful. We discussed this back in Unit 2. Please make sure that it is noticeable and it doesn't look like you have that written on your page. Make sure that we have the 4th root of y to the 7th, not 4 times the square root. And in the last one, I think we did a great job if we got down to 4. Okay. There is your practice quiz. Hopefully all that stuff made sense. What I want to do is do a very, very, very quick review of what was covered in those Professor Schmohawk videos. I'm not going to really review what we have in this practice quiz. I'm going to race through it pretty good. Okay, let's jump into the main focus. I want to focus in on question 3, but it's going to incorporate everything that we did in 1 and 2. On your page, what I'd like you to get down is just a power, a to the exponent m over n. And what I want to do is I want to break down 2 different ways that we can consider that expression. So if we have that power, then one of the ways we could tackle it, I'm going to put it in I'm going to put it in green, is that we could have chosen to break up that exponent. What I mean by that is we know that could have been the case. I just want you to look at the green, and we can see that had I had a power raised to another exponent, then I would multiply my exponents, and if I multiply m times 1 over n, then I get back to my original, m over n. Now, if I choose to view it that way, then what that tells me is to take the nth root of a over m. Now, I want to stop there for a second because this was all covered in those videos. I'm not assuming that we're automatic with it, though. If we struggled with that, then what I want us to do is just to get down a little bit of notation. That is that power, or that m, represents a power to some terms. Now, I don't like using that terminology because really a to the exponent m over n is all a power. But I'm going to argue to you that acts like your power. The better way to kind of think of that then is to say that the top would act as your power and the bottom acts as your root. And so if you take a look then at my green solution, then you can see how me going to that bottom, the n acts as my root, my m as my power. Okay, if we're good with that instance, then we could view it that way. And now what I want to do is just take a different approach. Maybe we tackle it the orange way. And that is, if I recognize that really that fraction could have been created by a power raised to another exponent, then maybe I have this as the way I think about it. Notice we would get back to our original again, because if I'm multiplying my exponents, I can multiply in any order. What does that enable me to do? It enables me to think of it this way, that I then have the nth root of a, and that is all raised to the exponent m. Notice I have my nth root and all raised to a power of m. Now, you may take a look at that and you may go, but I don't really see what the point is. Like, I understand that I could view it both ways, but like, why are you spending so much time on this? I'm going to shrink this down to make sure that we're good. So what I want to do is I just want to throw up one more example. And so over here in blue, I'm going to throw up the example. What if I asked you to calculate 27, to the exponent 2/3? Now, we can talk about how we're going to use a calculator to do this, but I need everyone in here to know I would expect you to do that without a calculator and in about 5 seconds. We're not there yet. And I especially want us to see that we're not going to be able to do that in 5 seconds if we think about it a certain way. So what I'm going to do is I'm going to follow our two approaches. I'm going to follow the green method. That green method says, view that as 27 squared, all to the exponent 1/3. Which means that we're going to view that not by writing it down that way, because I want us to know that's almost acting as if we don't understand this exponent. So what I see within that 2/3 is I have a power and I have a root. So what I can do is I can take the cubed root of 27 squared. That's what my green method says. I hope you can see why I say you're not going to do that in 5 seconds without a calculator. Because now you have to calculate what 27 squared is. Then you have to take the cube root of that number. And I'm going to argue to you, I think that that is your least efficient method. But if we could tackle that using the orange method, then I think we can do that in 5 seconds. What that orange method says is, why don't I take the cubed root of 27 first, then square it? And I think some of you will be done that in 5 seconds. Because you can already calculate the cubed root of 27. What multiplies by itself 3 times? What 3 factors are in 27? Well, that's a 3. And you can picture that 3. You even don't even have to write it down. Now all we have to do is square 3. And for a lot of us, we can go from 27 to the exponent 2/3 straight to 9 with no other work written. Take the cubed root of 27, which is 3, square it is 9, and there we go. So that's going to require a little bit of practice with it, but really, that represents that you understand what a fraction exponent is. It is broken up into your power and your root. Okay, this also then drives us, though, we're going to get into some problems where we are going to need our calculator. So the first thing I want you to look for is your generic exponent button. For a lot of us on our calculator, it may end up being something like x to the exponent y. So go on the hunt and try to find that on your calculator. If you don't have your calculator with you, no problem. I like the fact that you're trying this without. But maybe pause the video, go find your calculator and come back. Okay, that is a very common calculator button for us. Along the same lines, some people may have the X and the Y interchanged. That's okay. We may also see what almost looks like an accent in French. We've got that little circumflex, that little hat button, if you want to think of it that way. For most people, that is going to be your exponent button. And so you could enter in 27 to the exponent 2/3 using that button. Just make sure that we include our brackets around our 2/3. Now, the other thing that we have, since we recognize that we can be calculating some roots, is that you need to find your generic root button. That is, most of us should all know where our square root button is. So I want to make sure that we're not talking about that. Look on your calculator and maybe you have something like this, like an xth root button, or maybe your nth root button, like something like that. For some of us, it actually looks a little uglier because it in fact looks like your x is almost outside the root. It really means that you're finding the xth root. It's almost just telling you that you would have to punch your root button in first, your value, which root you're calculating. And for some of us, we even have a wyth root, although I really hate saying that out loud. So you go on the hunt, you find those calculator buttons, and what I want you to do is I want you to try entering in gold 27 to the exponent 2/3. And then what I want you to do is to try to use your purple button. Enter in the root independently, so like the cubed root of 27, and then square it. You see what your answer is. We need to get down to a value of 9, but I want you to work through your keying sequence on your calculator. I need you to know that if the only way that you can calculate 27 to the 2/3 is by using a calculator after a day's practice, you're not where you need to be. We should be able to calculate that with no calculator by halfway through today's lesson. I'm going to argue pretty quickly we should. Okay? It is important, though, that we understand our keying sequence and how to use that tool. Okay, let's jump in and play around with a few more practice problems. I want you to take a look right now at problem 4, and I am talking about these problems not in that you don't know how to find it. Number one, clearly you could use a calculator. Our focus on all of these, though, is going to be how do we do it without a calculator? And also I want to talk some strategies. Okay, we're going to work through these together. You're not pausing and trying them on your own. The first one, the cubed root of 64, you should be able to say that's 4 because you know 4 cubed off the top of your head. That is a problem in A. You just need to know. That is, you're going to spend the time practicing it. You're going to drill it in. That is one I would expect you to just know. Okay, let's take a look at B. We've got the 4th root of 81. Well, the first thing is, I would expect you to know that one as well. We should know that one because you know that 3 to the 4th is 81. So when it says find 4 things multiplied together that give you 81, 3 should be our answer. I do want to show you 2 alternate ways, though. The first one might end up being a factor tree. You might go through, just as you would back in the previous unit, and say, okay, that's going to be 2 things, so maybe 9 times 9, and that's a 3 times a 3, and a 3 times a 3. Ah, there's my 3. And so maybe we use a factor tree to get there. But the other thing that I want to bring to your attention is I want you to keep in mind that the fourth root of something is the square root of the square root. Now, at first, you might look at that and go, oh, really? Like, I wouldn't have. But I want you to think about what we just found out. That we know that a square root is an exponent 1/2. And so if I take the square root of the square root, then you might be able to see that now I have a power raised to another exponent. That means multiply those exponents. You get your confirmation of what you know automatically. You know that a fourth root is an exponent 1/4. It's now just us maybe working backwards to go, oh, well, that 1/4 is really just a 1/2 times a 1/2. And I think all of us can calculate the square root of the square root of 81 pretty quickly. Square root of 81 is 9. Square root of 9 is 3. So there are multiple ways to be able to go through and determine the fourth root of 81. Okay, now we come to C, and you have the fifth root of negative 1024. First thing I want to address, we have no problem with that because you have an odd root of a negative number. And you know that you can have the odd root of a negative number. Again, don't mistake that for us seeing a negative underneath a root sign and going, oh no, we can't calculate it. Just remember, had that been an even root, then that is not possible. Then that is an undefined value. Okay, so we're okay for the negative odd root. How would I recommend you guys know that? Well, the first thing is you're not going to know it. And I wouldn't spend any time trying to remember that. Memorize it. So how would we get there? I think this one is a default for you guys on using a factor tree. Like maybe we look at 1024 and we start to go, okay, it's even, so I know I can divide by 2. So I get like 2 and 5012. Now I do want to notice, I'm not writing down my negatives in my factor tree. We should be able to just tell that when you work your way through, the fifth root of a negative number is going to give me a negative number because I'm looking for something that multiplies by itself 5 times to give me a negative. That has to be a negative value. And now you start to work your way through and maybe you go like, well, 512 is like an even number, so I divide that by 2. And maybe we start to get to something that like we know, like maybe like we know that 256, the square root of that is 16. So that's 16 times 16. And maybe you can start to see within that, there's a 4, there's 2 4s, there's 2 4s. Hey, I have 5 4s in that factor tree. And there we go. Okay? It's not that you can't calculate those or you needed practice to calculate. I wanted to talk strategy on those 3. So A and B, I would expect you to know. A, absolutely. B, I hope that we could see that we could actually work our way through using the root of the root. Or in B and C, we've got factor trees at our disposal. Please don't discount your use of those, especially when your values get bigger. Okay, we're going to keep it going. Now we take a look at question 5. Again, I don't think you need to try these on your own. I don't think that's the point of these problems. What I want to address are 2 issues for you. And it's just to make sure that we don't do silly things. Okay, the first thing that we need to notice, the instruction says single power. It does not say simplify. So I am going to blindly follow that instruction. So in A, I have to write it as a power. All that means is just change it to an exponent. So we know that we have a cubed root. That becomes an exponent 1/3. Okay, we take a look at B. Now I have to go through and I have to write 1 over. Well, this is a line that you may wish to include, that my denominator written as a power is that. I just want to draw to your attention, that is not a single power. Look at my green expression. That is 1 divided by a single power. But that green expression is not a single power. So the way that I can write that as a single power is to move that power across the fraction line. That's going to make that exponent negative. I want you to notice that my red line is a single power. So you could have gone straight from the beginning right to the red. I don't need to see the green. But I do recognize that some of you are going to look at that red and go, but wait a second, that doesn't make sense because I have a negative exponent. And I'm going to go, who cares? What was the instruction? Right as a single power. Is the red a single power? Yes. So you followed the instruction. Don't worry about a negative exponent. The instruction was not to simplify. Okay, take a look at C. We take a look at C, and I would hope that we could go straight to something like this. That is, we notice that 3 represents my root. The exponent 7 represents my power, the top of that exponent, and we can change straight to that. I'm going to get rid of all those circles. I hope we can go one step. However, what you see in red is incorrect. And it is so common, it warrants me talking about it. I hope you notice that it's incorrect because I did not put brackets around my base. Notice what you have on the inside of those brackets. It is the cubed root of all of the negative 4. So I need to make sure that when I take my cubed root, it is of all the negative 4. It may work out to be the same value if I was to evaluate it, but I am not expressing it as a proper single power. So watch out for that. Common mistake. Okay, if we're good with that, then I want to go into one more type of problem as we work our way through. Let's take a look at question 6, and we're going to jump back to the instruction to evaluate. These ones, I want you to tackle on your own. So I think A offers a really good opportunity for you to consolidate what we talked about earlier. Can you calculate, the instruction, evaluate, 25 to the exponent 3/2 without a calculator? Okay, pause it now. Okay, we should be good. The way we should have been thinking about that one is taking the square root of 25 and then cubing it. I'm hoping that's the way we thought about it. Again, we don't have to show that. I hope we would just go square root of 25 is 5, 5 cubed, 125. Done. There we go. Okay, I want you to give B a shot. Pause it now. Okay, we're back. So you take a look at B, and I hope we would do the same thing. That we would be okay to think about that as the cubed root of -8, square it. And so we calculate that in our head. The cubed root of -8 is -2, square it is 4. Keep in mind, again, it is so much easier to take the root of something and probably make it smaller, then apply your exponent, your power, to blow it up to something bigger, as opposed to, if we focus in on problem A, trying to cube 25 in our head and then take the square root of that. Okay, most people are more comfortable shrinking things down and working with smaller numbers. So let's take the root first, then apply the power. Okay, you take a look at the last 4 problems for today. And what I would like you to do now is to try all 4. So I want you to get a solution down for every single one of those 4. Pause it now. Okay, we're back. So a couple things that I think we should focus in on C. I have to evaluate, so I have to calculate some stuff. Well, maybe I have a bit of an issue trying to calculate that negative exponent. So my strategy is going to be that I am going to flip the base because the base was a fraction. That's what changes the sign of that exponent. For you to go through and evaluate C, I have to see that red line. I need to see that strategy. But now that we've changed that to a positive exponent, feel free to just apply that exponent to all parts of the base. But you can calculate it right away. I know an exponent 1/2 means square root. So square root of 9 over the square root of 4. You come in on 3/2 and we are perfect. Okay, let's take a look at D. Now, I am hoping that no one was puzzled by the exponent of 0.75. We have spent all day addressing fraction exponents, rational exponents. So the fact that I happen to give you an exponent in a decimal form should not have blown anybody away, because you know you can always write fractions as decimals or decimals as fractions. So for us to look at that, I would need to see everybody change your exponent into a fraction. You got to show me that. But now you can calculate it right off the bat. We know that we can take the 4th root of 81, and hopefully we know that that is our 3, and now cube it. You come in on 27, and we are doing great. Okay, we take a look at E. Now, I wanted to throw at E at you because, again, let's start throwing in some negatives in a bunch of spots. Question E really is question C, just maybe a little uglier. We take a look at that, and your first step should have been, let's address the negative exponent on our base. So for me to go through and tackle that, well, that means I'm going to flip my base. And you notice we're actually coming in on a problem we've already dealt with today. This is question B. I can go through and calculate it real fast. The cubed root of -8 is -2. Square it gives me 4. Okay, question F. That's one that I hope we would have been really fast on. I would be totally okay for you to go through and just tell me 2. Because you see, the square root of 64 is 8, and now the cubed root of 8 is 2. However, what I want to do is I want to show you a different solution to F as to where we go on our next day. I would have had a bunch of people that could have looked at it this way. Well, I've got 64, and what's around it is a square root. Well, I know a square root is an exponent 1/2. And then what we have around that is a cubed root. Well, I know that a cubed root is an exponent 1/3. And maybe we change that into powers, exponents. So if I was to go through and simplify that, I have a power raised to another exponent. That means I'm going to multiply those exponents. And really what I need to calculate then is the 6th root of 64. So can I find 6 of the same factor in 64? Yep, 2. And maybe you just gave me the blue solution. The blue solution is going to be where we go next. Okay, I'm hoping that through those introduction videos, you guys had a little bit of an entertaining introduction to today's topic. I think it really explains some good theory and quickly shows you guys some good examples. I've hoped that through this video lesson, we've been able to kind of go through and readdress rational exponents. And now we've got some strategies to be able to work through to simplify some things and calculate some things. Okay, jump in, get your practice. Hopefully everything goes well. Good luck.